Hello students, we are going to study class 9, chapter 1, matter in our surroundings. In this, we are going to study what is matter, classification of matter on the basis of physical state and chemical composition, characteristics of particles of matter, the differences in the three states of matter, solid, liquid and gas. The three states of matter are interconvertible by change of temperature and pressure. We'll study what is temperature, how it is measured, and lastly, what is evaporation and implication of evaporation on its surroundings. Let us know what is matter. Everything in this universe that has mass and occupies space is called matter. You can see around yourself, chair, water, air, table, blackboard, all are matter. But feelings like hatred, anger, love, these are not matter, as they do not have mass. Modern scientists have classified matter based on the physical properties and chemical nature of matter. On the basis of physical properties, matter is classified into 5 types: solid, liquid, gas, plasma, and Bose-Einstein condensate. Solid, liquid, and gas you already know from your previous classes, and we will be doing in detail about these three in our next slides. Let us see here what is plasma and Bose-Einstein condensate. Plasma is a state that consists of super energetic and super excited particles in the form of ionized gases. Fluorescent tubes and neon sign bulbs consist of plasma. Bose-Einstein condensate. Satyendranath Bose did some calculations for another state of matter. Later, Albert Einstein, based on these calculations, predicted the fifth state of matter and called it Bose-Einstein condensate. In 2001, Eric A. Cornell, Wolfgang Ketterle, and Carl E. Wyman received Nobel Prize for achieving this condensation. This condensate is formed by cooling a gas of extreme low density. Density is as low as 100 or 1000 of air density to super low temperatures. Students, plasma and Bose-Einstein condensate are given in a box of more to know in your textbook, so it may not be asked in your exams. On the basis of chemical composition, matter is classified into two types: pure substances and mixtures. Pure substances are substances that contain only one type of particles or single type of matter. Mixtures, on the other hand, contain more than one type of pure substances. Pure substances are further classified into elements and compounds. Elements are pure substances that contain only one type of atoms. Compounds, on the other hand, contain more than one type of atom. Let us understand this by example. Hydrogen, oxygen, nitrogen, all are elements because they contain single type of atom. For compounds, we can take the example of water, which consists of hydrogen and oxygen, but in a fixed proportion. If it consists of hydrogen and oxygen, two types of atom, then why it is considered a pure substance? It is because it consists of hydrogen and oxygen in a molecular form. So the compound water will contain all H2O molecules and nothing else. Similarly, mixtures are also classified into two types: homogeneous and heterogeneous mixtures. Homogeneous mixtures are mixtures which have a uniform composition and are stable, whereas Heterogeneous mixtures are mixtures which have a non-uniform composition and are not stable. We can take the example of sugar and water for homogeneous mixtures. If it is kept or stirred, it remains as it is. For heterogeneous mixtures, we can take the example of sand and water. If it is kept and then stirred, the composition changes. So that is why it is a heterogeneous mixture. We'll be studying other properties of pure substances and mixtures in my next video on chapter 2. Let us study characteristics of particles of matter. Now we know that matter is made up of particles, and these particles are very small. Particles are generally so small that they cannot be seen. Exceptions are there, like in mixtures of sand and water, particles of sand can be seen. The other properties which all 9th class students must learn are: particles of matter are continuously moving, particles of matter attract each other, particles of matter have space between them. Let us study each of these property one by one. Generally, we don't see particles of a solid moving. They do vibrate on their mean positions. In solids like rubber and balloon, when they are stretched, movement of molecules can be felt. The movement of particles depends on the attraction between particles. If attraction between particles is more, the movement in particles will be less. And if attraction between particles is less, movement between particles will be more. We can see this in liquids. Liquids take the shape of the container in which they are kept. It is because the particles can move and the attraction between particles is less than in solids. Gases can even escape from the container if the lid of the container is kept open. So they have the least attraction between particles and the particles move faster. To understand the property particles have space, let us do an activity. Let us mix sugar cubes in 20 ml water. We see that the volume of water remains the same after the sugar cubes dissolve. This is because the particles of sugar takes the space in between water molecules. If we have understood the characteristics of particles of matter, it becomes easy to understand the differences between the three states of matter: solid, liquid, and gas. Let us see the characteristics of particles of solid. The intermolecular space between solids is absent, and the force of attraction between the molecules is very high. Because of this, solids are hard and rigid. They have a definite shape and have a definite volume. They cannot be compressed. The characteristics of particles of liquid are: the intermolecular space is moderate and the force of attraction between liquid molecules is also moderate. Because of this, liquids are not as rigid as solids and have fluidity, or they can flow. They do not have a definite shape and take the shape of the container in which they are kept. They have a definite volume. They cannot be compressed. The characteristics of particles of gas are: the intermolecular space is large here. There is no force of attraction between the molecules. So, because of this, gases are not as rigid as liquids and have more fluidity than liquid particles. Gases do not have a definite shape. Rather, they fill the container in which they are kept. They can escape if the lid of the container is open. Gases do not have a definite volume and they can be compressed easily. Students, the three states of matter which we have studied till now, solid, liquid and gas, are interconvertible. Interconvertible means they can be changed from one form to another. This can be done by heating or cooling the states. Let us learn the name of the processes which are used in this interconversion. If solid is heated and a liquid is formed, the process is known as melting or fusion. If liquid is heated and a gas is formed, the process is known as vaporization. And if gas is heated and a solid is formed, the process is known as sublimation. The inner circle of the diagram is shown by blue, which indicates cooling or decrease in temperature. So if solid is cooled and gas is formed, the process is known as sublimation again. If gas is cooled and a liquid is formed, the process is known as condensation. If liquid is cooled and a solid is formed, the process is known as freezing or solidification. In the previous slide, we have seen that change in temperature helps in changing the state of matter. What is temperature? Temperature is the physical quantity that tells us the degree of hotness or coldness of an object. It is measured by thermometer. The units of measurement depend on the type of thermometer used. Here I have taken three thermometers: Celsius, Fahrenheit, and Kelvin. The units of measurement are degree Celsius, degree Fahrenheit, and degree Kelvin respectively. What is absolute value? Absolute value is the lowest temperature at which the motion of particles which constitute heat are minimal. So absolute value for Kelvin is 0 degree. For Fahrenheit thermometer it is minus 459.67, and for Celsius thermometer it is minus 273.15. The freezing point of water is 0 degree on Celsius scale, 32 on Fahrenheit scale, and 273.15 on Kelvin scale. The boiling point of water, 100 degrees Celsius, 212 degrees Fahrenheit, and 373 degrees Kelvin. You can see here 0 degree Celsius is equal to 273.15 degree Kelvin. So this relationship can be used for conversion of temperature of degree Celsius to Kelvin and degree Kelvin to Celsius. For this conversion from Celsius to Kelvin, 273 is to be added, and for conversion from Kelvin to Celsius, 273 is to be subtracted. To make it easy, we can follow the series of English alphabets. K comes after C. So to reach K, we have to add 273. And to come back to C, we have to subtract 273. So 15 degrees centigrade is converted here by adding 273. It becomes 283. One more mistake which the students do: never add two different units of measurement together. Like I have written here 15 plus 273 degree Kelvin and not 15C plus 273. Two different units of measurement cannot be added. So once you add 273, it becomes degree Kelvin. Similarly, 200 degree Kelvin is converted to degree centigrade by subtracting 273. So I have not written K here. 200 minus 273 degrees centigrade becomes minus 73 degrees centigrade. Celsius and centigrade are the same. Celsius is a new term for centigrade. We have seen that state of matter changes with change in temperature. The temperature at which a solid changes to liquid state at atmospheric pressure is called its melting point. Melting point of ice is 0 degrees Celsius, which is equal to 273.15 degree Kelvin. The temperature at which a liquid changes to vapor state at atmospheric pressure is called its boiling point. Boiling point of water is 100 degrees Celsius, which is equal to 373.15 degree Kelvin. When solid reaches its melting point, the temperature of the system remains the same, unless all the solid particles are converted to liquid. So where does this heat go? The heat which is given to the solid is utilized in changing the state to liquid. The solid particles gain energy and are converted to liquid state. This heat is known as latent heat of fusion. Latent means hidden. Thus, the energy is more in particles of liquid than particles of solid at the same temperature. That is why ice has more cooling effect than water at the same temperature. Similarly, when liquid reaches its boiling point, the temperature of the system remains the same unless all the liquid particles are converted to gaseous state. The heat which is given to heat the liquid is here utilized in changing the state to vapors. Liquid particles gain energy and are converted to vapor state. This heat is known as latent heat of vaporization. Latent, as I told earlier, means hidden. So, particles of vapor has more energy than particles of liquid at the same temperature. That is why steam has more burning effect than water boiling at the same temperature. Let us now see the effect of change of pressure on the states of matter. You must have seen a water gun which is used to throw water or colors during Holi. The gun is fitted with a piston. When the piston is pushed downwards, the color from the nozzle comes out as the nozzle has an opening. To study the effect of change of pressure on the states of matter, I have taken a closed cylinder fitted with a piston in which gas is filled. When the piston is pushed downwards, the gas particles come close to each other. As there is no space for them to escape, the gas particles, on coming closer, becomes liquid. If the piston is further pushed down, the pressure will increase more and the liquid state is converted to solid state. Using the same principle, by increasing pressure and reducing temperature, gases can be liquefied or they can be converted to liquid state. Gases like CO2 is made solid CO2 by increasing pressure. Solid CO2 is also known as dry ice. Why dry ice? Because the state after increasing pressure has changed to solid. On decreasing the pressure again to 1 atmosphere, solid CO2 can come back to gaseous state without coming into liquid state, or it sublimes. The process is known as sublimation. Vaporization is a process in which a liquid is converted to vapors at its boiling point. Then what is the difference between evaporation and vaporization? Evaporation takes place from the surface of the liquid, whereas vaporization can take place from within the liquid too. Let us study what are the factors affecting evaporation. To understand this, I have taken the example of drying clothes for each factor. The first factor is higher the temperature, higher is the rate of evaporation. It is easy to dry clothes in summers than in winters. In summers, the air is hot and dry, so it can easily take the water which is evaporated from the clothes. The second factor is higher humidity in air decreases the rate of evaporation. We all know how difficult it is to dry clothes on a rainy day. On a rainy day, the air is already humid or it contains water vapors. So it cannot accommodate more water vapors which are evaporated from the clothes. The third factor is high surface area of liquid container increases the rate of evaporation. If clothes are spread on a string for drying, they will dry faster than if they are not spread, because the area in contact with air is more when they are spread. Based on this concept, sometimes it is asked why it is easier to sip tea or coffee from a saucer than a cup. The fourth factor is higher wind speed increases the rate of evaporation. On a windy day, the air in contact with clothes is more, so rate of evaporation is more. As evaporation requires the heat of the surroundings, evaporation causes cooling of its surroundings. Let's study some of the examples where evaporation causes cooling. Sweat from the body takes the heat of the body to evaporate, and it causes cooling of the body. Desert cooler cools the atmosphere, as water from the cooler, when it evaporates, it takes the heat of the surroundings to evaporate. Earthen pot cools water kept in it. The water seeps from the pores of the pot. It evaporates. For evaporation, it takes the heat of the water kept inside it and causes cooling of the water. Cotton clothes absorb sweat from the body. And when the sweat evaporates, it causes cooling effect on the body. Sometimes it is asked, what type of clothes should be worn in summers? There, we should write cotton clothes because it absorbs sweat from the body, and also light colored clothes as they reflect light. Reflection of light also causes cooling. Students, this is my first presentation for class 9 students on chapter 1. I have tried to incorporate all the concepts of the chapter in this presentation. If you have any suggestions or queries, please write in the comment section below. Like and subscribe my channel to get the notification of my forthcoming videos. Thank you.